This educational video is about mass spectrometry. The relative atomic mass of an element can be determined accurately by using mass spectrometer. You need to go through a few chambers before reaching to the ion detector. First of all, it must enter the vaporization chamber, followed by ionization chamber, followed by acceleration chamber, then magnetic field, lastly fall on the ion detector. Stage 1, where the vaporization happens. Any sample also must undergo this vaporization process, becoming in the vapor form and then injected into the ionization chamber. At stage 2, ionization. The atom is ionized by knocking one or more electrons off to give a positive ion. So it will only form positively charged ion. It can be positive 1 or it can be more than positive 1 as well. Most probably it will only knock for one time, so mostly we form only positive 1 ion. Stage 3, acceleration. The ions are accelerated so that they all have the same kinetic energy by an electrical field. After that, it will enter stage 4, where the deflection happens. The ions are then deflected by a magnetic field according to their masses. The lighter they are, the more they are deflected. The amount of deflection also depends on the number of positive charges on the ion. In other words, on how many electrons were knocked off in the first stage. The more the ion is charged, the more it gets deflected. These two factors are combined into the mass to charge ratio, or M to E ratio. For example, if an ion had a mass of 28 and a charge of positive 1, its mass to charge ratio would be 28. An ion with a mass of 56 and a charge of positive 2 would also have a same mass to charge ratio of 28 because by using 52 divided by 2. At stage 5, detection. The beam of ions passing through the machine is detected electrically. So this is also the diagram of the mass spectrometer. Here, first of all, it will enter here, vaporization chamber. All the sample will be vaporized in the gas form. Then enter ionization chamber. You can see we have the electric field here. Then it will accelerate. Deflect happen at the electromagnetic field. It needs to be adjusted so that it falls directly to the ion detector, not knocking to the wall. Once it knocks to the wall, it will combine with the electron left over inside here and then turn back to the atom with the neutral charge. So it cannot be detected by our ion detector. So we need to adjust the magnetic field so that it only falls to the ion detector. Here we also have a special place called the vacuum. Why we need the vacuum? The need for a vacuum is important that the ion produced in the ionization chamber have a free run through the machine without hitting air molecules. And then this will be the one. These are the mass spectrum being formed in the stick form. Okay, so this is how, for example, now we're going to discuss with an example. Okay, this example is by using chlorine 35 and chlorine 37, our chlorine gas. Okay, the following mass spectrum is obtained when a small amount of chlorine gas is analyzed in a mass spectrometer. Determine the relative atomic mass of chlorine, the relative molecular mass of chlorine. So from this mass spectrum, we have 35 and 37 for our chlorine 35 and chlorine 37, the two isotopes of it, and then it will form the chlorine in the molecule with two atoms. 35 plus 35, we have 70. 35 plus 37, so we get 72. And then 37 plus 37, we get 74. These are the three altogether, 2 peaks for the atomic ion. And then we have this molecular ion, form 3 peaks of it. Okay, solution for A. Chlorine 35 to chlorine 37 equals to 75.77% to 24.23%. Is also approximately to 3 to 1. So we can work out the calculation by using this. Relative atomic mass of chlorine equals to 35 multiplied 3 plus 37 multiplied 1 divided by 3 plus 1 equals to 35.5. It is important that the answer only present in 1 decimal point. The 1 decimal point also showing is coming from the average of the two isotopes. For B, to solve for B, the group of numbers M to E 70, 72 and 75 is due to chlorine molecules, Cl2. The possibility of finding a chlorine 35 atom is 3/4, whereas the probability of finding a chlorine 37 atom will be 1/4. So, for